Hi, and welcome to our second junior relations video. In this video, we're going to talk about reading and understanding 2D graphs. Now, in the last video, we introduced a diagram called a Cartesian plane. We talked about an x-axis, which goes across horizontally, and a y-axis, which goes vertically, y to the sky. We also talked about the point where the two axes meet, and that's called the origin. So what we're going to do is we're going to now look at some 2D graphs and start to figure out how to understand and interpret them. But first of all, what do we mean by 2D? Well, 2D means two-dimensional. We have an x-axis is one dimension, the first dimension, and the y-axis becomes our second dimension. Now in this video, we're going to look at 2D graphs, but at some stage in our mathematics, we're going to introduce three-dimensional graphs. 3D means three-dimensional, and they have an x-axis, a y-axis, and then a z-axis. All right, let's get straight into example one. Now look at this example. We have a couple of names of dots on the graph. On the x-axis, we have the age, and on the y-axis, we have the height. So here's some questions. Who's the tallest person? Well, when we talk about tallest, we're talking about height. So we must be looking at the y-axis. And you can see that Ernie is the highest up on the y-axis. So Ernie must be the tallest, or Ernie is the tallest. Right, who is the youngest? Well, we're talking about age now, so we're looking at the x-axis. So we're looking at the person who's the youngest, the smallest on the age, and that must be Anna. Anna is the lowest on the age, the x-axis. What can we say about Ernie and Claire? Well, interesting, we can say this about them. They are vertically on the same line, so therefore Ernie and Claire must be the same age, but different heights. Right, this is a family of two parents, two children, two parents, and one grandparent. So who's who? Well, I'm going to answer this question based on age. And I'm going to take them all the way back down to the x-axis, the age, and I'm going to say Anna must be the youngest because she's the least on the age. Brad's the next oldest, so they must be the kids. We've got Ernie and Claire are the same age, so I assume they're the parents. And Dave is right up on the right-hand side of the age, which means he's the oldest. So I reckon Dave is the grandparent. All right, example 2. Here's a graph. On the x-axis, we have time in minutes. And on the y-axis, we have the cost in dollars. And this is the cost of phone calls to the USA using a phone company called Teleamron. Right, so how much would a 5-minute phone call to the USA cost? So 5 minutes, we have to look at time, 5 minutes. Here's 5 minutes on the x-axis. And if I now go up and smack into my graph and take it across to my cost, we can see that a 5-minute phone call costs about $4. When we do these interpretations, we don't always get a perfect answer. We're just guessing. So I reckon it looks pretty damn close to $4. So we're going to say $4. Right, how long would a $5.50 phone call last? So this is money. So we'll go to the y-axis, the cost, and we'll draw a line at $5.50, which is halfway between 5 and 6. We'll whack into the graph, and then we'll take it back down to the time. And it's somewhere between 12 and 13. It looks pretty close to halfway, so we're going to say 12.5 minutes, halfway. All right, we're into example 3, and what we're going to do now is just draw a couple of graphs that represent some scenarios. So here's the first scenario. A goalie kicks a soccer ball high into the air to the halfway line. So all we need to do is draw distance along the x-axis and height along the y, and you can see that the ball starts at the origin. That's where the goalie is, and he kicks it up to its highest point, and then it comes back down and lands at the halfway line. Right, wages and income in New Zealand are increasing at a steady rate. Well, we're going to have the year across on the x-axis and the income on the y, and when we say steady, it's going up in a straight line at the same rate every year. Right, and finally, water's boiled in a kettle and left to cool. So we're going to have time across and temperature up, and it boils really quickly, and then it cools down pretty slowly. Right, thanks very much for watching.